Alright, what's up everyone? In this video we're going to be talking about solving exponential and logarithmic equations. So I'm just going to give you some examples and show you kind of some tricks for how we can simplify these equations to solve them out. So with this first equation here, what I'm going to do is try to get the same base on both sides, because I can see that this 100 we could rewrite as 10 squared. Let me change this. Alright, so we could rewrite this as 10 squared to the x, which would just be 10 to the 2x. This 1 over 10 we could write as 10 to the negative 1. 10 to the negative 1 to the x minus 3 power, we just multiply that, so that would be negative x minus 3. And you'll have to forgive my handwriting, writing with my mouse today. Alright, since both of these have the same base, that means the exponents have to be equal to each other for this equation to work. So we can go from this point and say that 2x has to be equal to negative x minus 3. So we could add the x over, so we'll have 3x equals negative 3. Divide by 3, and you'll get x equals negative 1. Alright, with the second equation, with these are really simple. If it's in exponential form, all you have to do is just rewrite it in logarithmic form, and most of the time it will already be solved for you. So if we rewrite this in log form, it would be log with a base of 2 of 7 equals x. And there you go. It is solved for x. Now, if you wanted an exact answer, you could plug that into a calculator and take log base 2 of 7, and you'd get your decimal answer. Alright, scrolling down, we're going to look at some different tricks here. So notice with this part A, we have natural logs on both sides of the equation. So whatever's inside that natural log has to be equal on both sides for the equation to be equal. So we can just rewrite this as 4x minus 7 equals x plus 5. We can subtract the x over here and we get 3x. Add the 7 over here and we get 12. Divide by 3 and you get x equals 4. Now the trick for part B is we are going to set the base. So we're going to set this whole thing as an exponent with a base of 2. I'm going to show you why here in a second. So we're going to do 2 log base 2 of 5x minus 17 equals, and we have to do the same thing over here, so the base is 2, and we'll set everything else as an exponent. And when you do this, this pattern over here, remember this is one of the properties we talked about with logarithms. Since this base is the same as the base of the logarithm, this simplifies simply to just 5x minus 17. And 2 to the third power is just 8. So we can solve this very easily. Add the 17 over. You'll get 25. Divide by 5. And you'll get x equals 5. Alright. Looking down at this next one, we're going to use one of our logarithm properties from the last section. So since this is a log plus a log, we could condense this into one log. And remember how we condense we kind of work backwards on our logarithm properties. So we could put this into 1 log. So it'd be log 2x times x minus 5. 2x times x minus 5 equals 2. We could simplify this a little bit. Actually, yeah, we'll go ahead and simplify it. 2x times x is 2x squared. And 2x times negative 5 is negative 10x. All right. Now, to get rid of the logarithm, we can kind of do the same trick we did a second ago. We know the base of this log is 10. So if we raise this whole thing as the exponent with a base of 10 and do the same thing over here, then this base and this base will cancel this whole thing out to where all we have left is the exponent. So we'll have 2x squared minus 10x equals 10 squared is 100. Now it looks like we've got a quadratic equation here. One thing we could do is divide everything by 2, so we'd get x squared minus 5x equals 50. And why don't we subtract that 50 over as well? So if we do that, we'll get minus 50 equals 0. I think we could solve this using factoring. So let's try that. So we'll have x. Since there's a minus sign right here, we'll have a plus and a minus. What times what gives us 50? We could try 5 times 10. 5 times 10, so 10 here, 5 here. And then add them up and see if you get that negative 5. Negative 10 and 5 is negative 5. So that works. And then we can see that one of our answers is going to be negative 5 because negative 5 plus 5 is 0. So x equals negative 5. And then also the other one has to be 10 because 10 minus 10 equals 0. So x equals 10 for our other answer. So there you go. There's your 2 solutions for that problem. All right, with this next problem, it's an inequality, but we solve it out the exact same way. I guess what we could do here is rewrite this as a logarithm. And I think, and I want to make sure that I'm telling you right here, yeah, it won't affect the direction of the sign. So let's rewrite this as a logarithm. So we'll have log base 3 of 20 equals x. And, oh, not equals, is less than x. And again, I want to double check and make sure that that's correct. And it looks like it actually, when we rewrite that, looks like it flips the sign if we do it this way. Or if you keep the x on the same side, there's x less than, so this should also be x less than. So there we go. So this is the correct solution for that. All right. We could do something similar down here. We could, we know the base of this is 10, so let's do that same trick we already did. Let's raise both sides with 10 as the base. So if we do that here, we know there's a 10 here and a 10 here, so all we'll be left with is an x less than or equal to 10 squared is 100. And I want to double check and make sure that's right, and it is. That's correct. Okay. So that's just some of the tricks you can do to solve logarithmic and exponential equations. But if you have any questions, just let me know, and I'll see you in the next video.